So in this question, we're going to look at getting the true shape of a plane or laminate. Now, on the slide it says edge view and true shape. The reason for this is, in order to get to true shape, we're going to first get an edge view. So, just going to come here to my SolidWorks file. As you can see here, we have a plane here drawn ABC, and we have the vertical plane, the horizontal plane, just drawn in for reference as well. Now, if I go to window view, change this my elevation. Plan. Sorry. Now, as you can see here, I have my surface. My surface is just going to take off rotate view. If I go into my elevation and I draw a horizontal line in my elevation across the plane, that is going to become a true length in my plan. And that's given me a reference line in my plan that I can use. Alright, so I'm just going to turn this off and just go back to one window view. I now have this line, and as we can see, if I look into that line and make it a point, that's going to give me an edge view. Now, as we've learned before with orthographic projection, if we have an edge view of a surface, if we take an auxiliary on from that edge view, that auxiliary will give us the true shape of the surface. So we're just going to go here. Now, in my elevation, I'm going to draw a horizontal line from point C. You do not have to use point C. Obviously, you can't use point B or A, because if you go from those 2 points, it will not hit your plane and your point. I could just take a horizontal line from any point at all, but because I have C already, it just gives me a reference point to my plan, which is easier to work with. Next, that horizontal line hits BA. I'm going to bring that down and hits my plan here. Now, as I've shown you from the SolidWorks video, this line now is a true length. That's a true length line. So what I'm going to do is I'm going to get an auxiliary elevation looking in my true length, and that's going to help me get an edge view of my plane. Sorry, just label all your lines. Now this is my X1, Y1. Because this view here is a plan, this has to be an auxiliary elevation. And as it's an auxiliary elevation, I'm going to take my heights from my original elevation. Now when I join my 3 points together, they all line up perfectly, and that gives us an edge view. Now, from my edge view, my next move, so zoom in there a tiny bit, my next view is going to be to get a true shape. So what I'm going to do is I'm going to look in here. Okay, I'm looking in here. My X2, Y2, so this is an X2, Y2, and as you can see, this is parallel to my edge view. That's very important. This is parallel to my edge view. This was an auxiliary elevation, so this view here is going to become an auxiliary plan. And I'm going to bring all my points perpendicular to it. Now, because this is an auxiliary plan, I'm going to take my distances from my X1, Y1 line back. As you can see, this distance here is quite large and it may not fit, so I'm going to put in a datum line. A datum line is a line we put in. It's as if we're moving our X1, Y1 line back just to take the exact same distance of each measurement. So I'm just going to put B on the ground, and I'm going to call this my datum line. Always just indicate if you are using a datum line, so the person reading your question understands where you've taken your measurements from. So I have point B, C, and A. And this here now is a true shape. By getting this true shape, it allows me to measure the length of any one of the three lines, and it also allows me to measure any one of the three angles. So to recap, we take a horizontal line which gives us a true length line in my plan. I look into my true length line in order to get an edge view. Once I have my edge view, I then get an x2, y2 line which is parallel to that, taking all my distances from my x1, y1 line back, and this allows me to get a true shape of my object.